Alright, so this time would evaluate limits of sequences, and this follows from the limit principles we have stated previously. Right, so you can kindly maybe open them side by side and visualize them as we use them. Alright, so the first question is this one, and you have to find the limit of this. Right, now usually trying to evaluate something like this is quite easy. When you see such a question, right, try as much as possible to make the numerator and the denominator factorize to the smallest power of n, so to say, right? This is what I'm trying to say. When you are approaching infinity, right, and the denominator is the variable in question, right, it makes more sense if the denominator has a higher power, right? So there's it. You have to factorize n out of the numerator, n out of the denominator, right? Or someone can also say divide both numerator and denominator by n, right? But I realize that when you do only n, it won't work because the highest power in the numerator is n squared. So it means that it has to be n squared for the numerator, n squared for the denominator. And now when you do that, this is what you see, right? So 4 divided by n squared will give you 4n squared, 4 over n squared. Then 2n divided by n squared will give you 2 over n. Then minus 3n squared over n squared will give you n. Yes, and that follows, right? Now you do the same thing for the denominator, right? Now remember that when we are taking limit of a fraction, it's equivalent to taking the limit of the numerator and the limit of the denominator as well, right? So it's exactly what we'll do here. Now, all what we have done is the same expression, right? But we've just rewritten it with the limits using the limits theorem applied. 4 over n squared minus 2 over n minus 3. Now, when you take the numerator alone, you realize that if you let n approach infinity, right, then 4 over n squared as n approaches infinity will be equal to 0. It's the same thing for minus 2 over n. As n approaches infinity, it will be equal to 0, right? So you realize that at the end of the day, the numerator will be left with only minus 3 over. The denominator also has the same problem. When the 4 doesn't have any variable which can approach, so the limit will be 4 plus 5 over n. If n approaches infinity here, this 5 over n will become what? 0, right? So you get 4 for the denominator, right? So at the end of the day, your answer is supposed to be minus 3 over 4. I don't know what warrant that mistake here, but your answer is supposed to be minus 3 over 4, right? And that's what you see. Now, it's the same thing for the next question. So the next question, you have this, and you have a bunch of square roots and everything. But you can take your time, relaxing. Let's go through step by step. So the first procedure, right? Try as much as possible to factorize some n out. Like, don't make the whole point is don't make this expression approach infinity, right? If there is some value of n which you can use to divide the expression such that you will get the n's in the denominator rather than as a numerator, it's more likable. Okay, so now when you are finding limits of this expression in the root, it's equivalent to finding the limit of the expression, right, with the root outside, right? This is also one of the properties. Now, so you still have the same expression. Now you realize that the highest power of n is 3, right? So you divide numerator and denominator by what? N cubed, right? So realize that here when you divide by n cubed, you would attain 1 minus 1 over n. Of course, you first have to expand this bracket before you divide by n cubed. I'm hoping you already know that. And when you divide the denominator also by n cubed, you obtain 1 over n cubed plus 1 over 2n, right? And now we start setting our variables to infinity. as this n approaches infinity, this expression approaches 0. The same for this expression. So the numerator will be left with 1, the denominator will be left with what? 1 over 2. And 1 over 1 over 2 is just what? Square root of 2, right? 1 over 1 over 2 is the same as 2, right? This is just equivalent representation. And that's it. You have the limit of the expression. In this part, you had square root of n squared plus n minus n. So when you have such an expression, this looks like a set, right? There is the part under square root and there is the real part, right? So what you do is that you multiply the numerator and the denominator by the conjugate, or the conjugate of the set, right? So let's take a look at that. So this is the expression, right? And now remember that this expression is actually a fraction, right? So as usual, it's over 1. So you multiply the numerator and denominator by the conjugate, right? So the numerator originally is square root of n squared plus n minus n. And you multiply by its conjugate, which is square root of what? N squared plus n plus what? N. Because here was negative, so here has to be positive, right? Over square root of n squared plus n plus n, right? I said you multiply the numerator and the denominator by what? The conjugate. Now, what you come and realize is that this is just difference of two squares, right? This expression you see at the numerator is just difference of two squares. So it's like you have a plus b times a minus b, right? So what you do is that you can just square this one, subtract it from the square of this one, right? So you get square root of n squared plus n. That is if you square only this one, right? The square will cancel the square there, minus n squared all over. The denominator hasn't changed. It is still n squared plus n outside. And this expression can be simplified to what? N over square root of n squared plus n outside. As simple as that. Now you can proceed. Now we are actually finding the limit, so we have to proceed, right? And in our procedure, we realize that now we have this and we must simplify it. Okay, so we go ahead, like I always say, divide the numerator and the denominator by n. Okay, so when you divide the numerator by n, you get 1. N over n is 1. The denominator, when you divide by n, you get square root of n squared plus n over n plus n over n. Okay, and this is also 1, which comes to give you 1 over square root of n squared plus n over n plus 1. Now, there is a short convincing I want you to convince yourself. Can you convince yourself that this expression you see here, this small expression, right, is actually the same as a big square root n squared plus n all over n squared? Can you? Yes, it's actually the same thing. I mean, the square root can be split between numerator and denominator. Remember your sets, right? So it becomes n squared plus n here over what? Square root of n squared, and which is n, right? So realize that this one becomes equivalent to this one, right? So that's what you do. You actually do the inverse operation. That's the reverse procedure. You put everything under the square. So this becomes n squared plus n all over n squared, and the outside is plus 1. Okay. Now you move on to the next step, which just involves simplification. Okay. So this become 1 over, you have a big square root. Now this n squared, this can be written as n squared over n squared plus n over n squared. Should have been doing this, but let's be thorough, right? And you can rewrite it as 1 over square root of 1 plus 1 over n, right? In this is the plus 1, right? So now you have this. Now you realize that this expression, right, has elements which can go to 0 if you put in infinity more than the original expression, right? And that's why we go through all this hassle, right? So you realize that in their procedure, they go through the same step and they come to get that, right? And now I input n approaches infinity here, right? You get 1 over 1 square root of 1 plus 0, right? Which will give you 1 plus 1 eventually and 2. That's the procedure, right? And step by step. Now I'm actually expecting you to use that same procedure to evaluate for the very last question, right? So this brings us to the end of this video. You can continue to ask your questions in the comment section and we'll tackle them immediately. Continue to like, share, and subscribe. Goodbye.